Good morning class. Today we start chapter 4 chemical bonding. Before starting this chapter, now let us consider what is chemical bond. The force of attraction which bind atom within molecule is said to be chemical bond. I repeat again, the force of attraction which bind atom within molecule is said to be chemical bond. Student, chemical bonds are of two types. Chemical bonds are of two types. These are the strong chemical bond and weak chemical bond. Chemical bond are of two types. These are the strong chemical bond and weak chemical bond. Strong chemical bonds are of further four types. These are, the number one is the ionic or electrovalent bonds. The second type bond is covalent bond. The third type is coordinate bond, or sometimes say to be dative bond, and the fourth type is the metallic bond. On the other hand, the bond which are weak in magnitude are of two types. These are van der Waals forces and hydrogen bond. Hydrogen bonds have further two types. These are intermolecular and intramolecular. I repeat again, chemical bond, the force of attraction which bind atom within molecule is said to be chemical bond. Chemical bond are of two types. These are the strong chemical bond and weak chemical bond. Strong chemical bond has four parts: ionic or electrovalent bond, covalent bond, coordinate or dative bond, and metallic bond. While the weak chemical bond are of two types: van der Waals forces and hydrogen bond. In which two categories are there in hydrogen bond? Intermolecular and intramolecular hydrogen bond. Now, before starting this chapter, now let us consider why do atom combine with each other. Atom combine with each other to attain stability. I repeat again, atom combine with each other to attain stability. Now let us consider Lewis symbol. Lewis symbol or Lewis notation, same thing. Students, Lewis symbol indicate the valence shell electron atom by putting dot surrounding the atom of an element. For example, sodium has one electron in their valence shell, so its Lewis symbol is represented by n dot. Chlorine has 7 electrons in their valence shell, so its Lewis symbol is indicated by putting 7 dot or cross around the symbol of chlorine, that is Cl, like this manner. Similarly, oxygen has 6 valence electrons, which can be shown by putting 6 dot around the symbol of oxygen. So these are called Lewis symbol or Lewis notation. Now let us consider octet rule. The atom of different elements combine with each other in order to attain their nearest noble gas configuration. I repeat again, the atom of different element combine with each other in order to attain stability by acquiring noble gas configuration is said to be octet rule. Now there are some limitation of octet rule. These are: the compound containing hydrogen not obey octet rule. For example, the best example of it is hydrogen. Since hydrogen has one electron in the outermost shell, when it combines with one more electron of hydrogen of other atom, like this manner, octet is not complete. Instead of duplet, here the duplet complete, not octet. So it is an exception of octet rule. Number second, compounds which having incomplete octet. Compound which having incomplete example is BeH2. Beryllium has 2 electrons in their outermost shell. Hydrogen further have 2 electrons in their outermost shell. Since beryllium has incomplete octet, therefore octet rule is not applicable. There are some compound in which expanded octet is there. Expanded octet means which contain, in which the central atom contain more than 8 electrons. Best example is PCl5. In PCl5, as we know, chlorine has 7 electron in their valence shell, while phosphorus has 5 electron in their valence shell, like this manner. Chlorine complete its octet by sharing 1 electron of phosphorus, like this manner. This is also done by chlorine by sharing 1 electron of phosphorus, like this manner. Since we notice the phosphorus atom, that is the central atom of this compound, contain total number of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 electrons. So it is an example of expanded octet. Now there are some limitation of octet rule which contain odd electrons. For example is NO. In case of NO, nitrogen has total number of 7 electrons instead of 8. 1, 2, 3, 4, 5, 6, 7. So it is an example of odd electron molecule. So these are the some examples which not obey octet rule. Now let us consider ionic bond or electrovalent bond. Student, the bond formed by transferring of electron. I repeat it again. Ionic or electrovalent bond, the bond formed by transferring of electron is said to be electrovalent bond. Example is NaCl. In this case, sodium has 1 electron in their outermost shell, while chlorine has 7 electrons in their outermost shell. Sodium has a tendency of losing 1 electron to acquire its nearest noble gas configuration. Similarly, chlorine has a tendency of accepting this lose electron to acquire its nearest noble gas configuration. Thus, Na bears single positive charge by losing of electron, while the Cl bears one negative charge due to gaining of electron. Thus, we can say that neutral NaCl will form. Let us take one more example. Calcium oxide. Calcium has 2 electrons in their outermost shell. Oxygen has 6 electrons in their outermost shell. Calcium has a tendency of losing these 2 electrons to complete its octet by acquiring nearest noble gas configuration. Similarly, oxygen has a tendency of gaining these 2 electrons to complete its octet. Thus, calcium bears 2 positive charge and oxygen bears 2 negative charge, or we can say that CaO will form. So, we notice the ionic or electrovalent bond are formed by transferring of electron. The number of electron lost or gained during this process is said to be electrovalency. Now, there are 3 factors which affect the formation of ionic bonds. These are: number 1, low ionization enthalpy. Low ionization enthalpy means the tendency of losing electron. If the tendency of losing electron by the metal is low, it facilitates the formation of ionic bond. The second is high electron gain enthalpy. And the third one is the high lattice enthalpy. It should be noted, if there is high lattice enthalpy, the stability of ionic compound is more. That is why MgO is expected to be more stable as that of NaCl, since the magnitude of charge on ion is more as compared to NaCl. Now, let us, one most important thing must be noted: when the electronegative difference between two elements is greater than 1.9, then only ionic compounds will form. I repeat again, when electronegative difference between two elements is greater than equal to 1.9, then only ionic bond is formed. Now let us consider covalent bond. The bond formed by mutual transferring of electron. I repeat again, the bond formed by mutual sharing of electron. I repeat, the bond formed by mutual sharing of electron is said to be covalent bond. For example, hydrogen. Hydrogen has 1 electron in the outermost shell, another hydrogen has 1 electron in their outermost shell. First hydrogen share 1 electron of other hydrogen to complete its duplet. Similarly, case done by second hydrogen atom. Thus, by sharing of 2 electrons, H single bond H is formed. The second example is O2. Oxygen has 6 electrons in their valence shell, Another oxygen also has 6 electrons in their valence shell. First oxygen share 2 electrons of other oxygen to complete its octet. Similar process done by second oxygen atom. Thus, by sharing of 4 electrons, O double bond O is formed. Now let us consider the third example. N2. Nitrogen has 5 electrons in their outermost shell. Another nitrogen also has 5 electrons in their outermost shell. First nitrogen atom share 3 electrons of other nitrogen atom to complete its octet. This can be done by other nitrogen atom also. By sharing of 6 electrons, we will obtain triple bond. So we notice the covalent bond is formed by mutual sharing of electrons. Now let us consider the third one, that is the coordinate bond. Coordinate bond is also formed by sharing of electron but from one side only. I repeat again, coordinate bond or dative bond is formed by sharing of electron from one side only. For example is ozone, O3. Let us show the formation of ozone. As we know that oxygen has 6 electrons in their outermost shell, like this manner. First oxygen atom share 2 electrons of the other oxygen atom to complete its octet. Similar process done by second oxygen atom also. Now third oxygen atom complete its octet by sharing of 2 electrons of second oxygen atom. Since sharing takes place from one side only, thus we can say that coordinate bond is formed. Coordinate bond is shown by arrow whose direction is from donor to acceptor. Now let us consider one more case. It is H2SO4. In formation of H2SO4, hydrogen has 1 electron in their outermost shell. Oxygen has 6 electrons in their outermost shell. Hydrogen share 1 electron of oxygen atom to complete its duplet. Similarly, oxygen share 1 electron of hydrogen, 1 electron of sulfur to complete its octet. Now, these oxygen are not have complete octets. So, they complete octet by sharing these 2 electron of sulfur atoms. Thus, the coordinate bond formed in sulfuric acid are of type like this one. Now, let us consider metallic bond. The bond formed between metal atom is said to be metallic bond. It is the metallic bond due to which metals have high melting point and high density. Now, let us consider hydrogen bond. The bond formed between the hydrogen and the electronegative element like fluorine, oxygen, nitrogen is said to be hydrogen bond. Hydrogen bond is shown by dotted lines. Hydrogen bonds are of two types. It is intermolecular hydrogen bond and intramolecular hydrogen bond. Now let us consider one by one. Intermolecular hydrogen bond form between two molecules of same kind or different kind. I repeat it again. Intermolecular hydrogen bond are formed between the molecule of same kind or different kind. The best example of it is water. In case of water molecule, hydrogen bond shown by dotted lines. Then the hydrogen bond is shown by this manner also. Since hydrogen bond formed between two molecules, it is called intermolecular hydrogen bond. One more important example of it is HF, hydrofluoric acid. The hydrofluoric acid is shown by this manner also. Here fluorine bears partially negative charge, hydrogen bears partially positive charge, and so on. Now the second type of hydrogen bond is intermolecular hydrogen bonds. Student, intermolecular hydrogen bonds are formed within molecules. As we know that hydrogen bond is shown by dotted lines. In best example of intermolecular hydrogen bond is orthonitrophenol. It is orthonitrophenol. It is orthonitrophenol, in which the hydrogen bond formed within molecule. So it is called intramolecular hydrogen bond. It is called intramolecular hydrogen bonds. I repeat it again, the bond formed between hydrogen and most electronegative element like fluorine, oxygen and nitrogen are said to be hydrogen bond. Hydrogen bond are of two types, intermolecular hydrogen bond and intramolecular hydrogen bond. When the hydrogen bond formed between molecule of same kind or different kind, it is said to be intermolecular hydrogen bond. When the hydrogen bond formed within molecule, it is said to be intramolecular hydrogen bond. As we described earlier, hydrogen bond shown by dotted lines. Actually, in hydrogen bond, dipole-dipole interaction take place. The strength of hydrogen bond is very small as compared to the covalent bond. Now, let us discuss formal charge. The actual charge present on an atom, I repeat again, the actual charge present on an atom is said to be its formal charge. The actual charge present on an atom is said to be its formal charge. It can be calculated with the help of formula. Formal charge is equal to total number of valence electron in free atom minus total number of non-bonding electrons minus 1/2 total number of bonding electrons. Now let us consider the case of ozone to calculate formal charge. Ozone. The structure of ozone is drawn like this manner. Let us consider this to be atom 1, this to be 2 and this to be 3. Now let us find the formal charge on first. According to the formula, total number of valence electron in free atom, since oxygen is there, oxygen has 6 valence electron. Now minus total number of non-bonding electron, 1 2 3 4 4 non-bonding electron is there. And how many bond, and total number of bonding electron, how many bond are formed? 2 bond are formed, which involve total number of 4 electron. The 6 minus 4 minus 2 gives 0. That is, the first atom doesn't contain any charge. Now let us consider second one. Formal charge on second. Total number of valence electrons 6. Non-bonding electrons are 2. Bonding electrons are 6. On calculating, we get 1 positive charge on second. Now let us consider the formal charge on third. 6 valence electron is there. Total number of non-bonding electrons 6. Bonding electrons are 2. On solving, we get -1. Thus, the actual representation of ozone molecule is like this manner, in which this second atom bears positive charge and third bears negative charge. So, the actual charge present on an atom is said to be its formal charge. It can be calculated with the help of formula. Formal charge is equal to total number of valence electron in free atom minus total number of bonding electron minus 1/2 total number of bonding electron. Thank you very much.